Am I sharing my screen? I think I forgot to share my screen. Forgot to share the screen. Okay. So here we go. Sharing the screen now. All right. So we're sharing the screen to do this problem number 9 from section 3.4. We're going to ask a series of questions based on the graph of this curve, and this is a graph of velocity. All right. So typically what we say is that when velocity is positive, we are going forward or up, depending on the situation. When velocity is negative, we are going down, or sorry, probably put it this way. We are going backward or down. All right? So our first question, when is the particle moving forward? Well, that's asking the question, when is the velocity positive? Here the velocity is positive, so I might say, yeah, it looks like it's positive on the interval from 0 to 1. And here the velocity is positive, so add on to that the interval from 5 to 7. So there's forward. Okay, what about backward? Well, backward is when the velocity is negative. And there's only one time that it's negative, and that's from 1 to 5. So there we go, backward. Now here's the tougher one. When is it speeding up? Which we did not define in class yesterday. Okay. We're going to define speeding up 2 different ways. All right? First of all, speeding up and slowing down have to do with speed, not velocity. And what's our definition of speed? It is the absolute value of velocity. So here I am in red marker drawing the speed curve. Okay, got it? All right. So, when is it speeding up? Whenever the speed is increasing. Okay? So let's call speeding up means speed is increasing. Okay, well, where is that on this particular drawing? Well, here, oh no, there's the speed curve, but it's getting lower and lower and lower. Okay, that's slowing down. Slowing down means speed is decreasing. All right, so I'm going to say it's slowing down on the interval from 0 to 1, and then it goes what? The speed goes up, so it's speeding up from 1 to 2. What happens here? It's maintaining a steady speed. It's not speeding up, it's not slowing down at all. From here to here, it's slowing down. That's from 3 to 5. From here to here, from 5 to 6, it's speeding up. And then from 6 to 7, it's slowing down again. All right? So that's one way to do that problem. Speeding up means speed is increasing, and we have to look at the speed curve. But here's another way to look at this problem. All right? Another way to look at that same issue is speeding up is when velocity and acceleration are the same sign. And slowing down is when velocity and acceleration are different signs. Now, the best way for me to demonstrate this is the idea that I throw this pen up in the air. Okay? So when I throw it on the upward side, is it slowing down as it's going up? Yeah. And once it reaches its high point and it starts coming down, is it slowing down or is it speeding up? It's speeding up. Okay? If we think on the upward side that velocity is going up, but of course acceleration is down, those two things are working against each other, and that's why it slows down. On the other side, velocity is going down, acceleration is going down, and that's why it's speeding up. So in order to answer the question this way, we'd have to say, well, what does the acceleration curve look like? Well, the acceleration curve is going to be the slopes of the velocity. So I don't know what that slope is, but it's negative. So I'm going to draw a negative slope here, or a negative, let's do this in black. Let's do it in dark black. There we go. So from 1 to 2, I got some sort of negative slope on my velocity curve. I have negative acceleration. All right? And then from 2 to 3, it's remaining steady. I've got no acceleration. I got zero acceleration there. From 3 to 4, I've got some kind of positive acceleration. Sorry, from 3 to 6, I should say. These should all be open circles, by the way. All right? And from 6 to 7, I've got some sort of negative acceleration. And then from 7 to 9, I got zero acceleration again. All right. So where do we have acceleration and velocity having the same sign? Well, do we have it here? No. Velocity positive, acceleration negative. That means slowing down from 0 to 1. From 0 to 2, negative acceleration, negative velocity. There's our speeding up from 1 to 2. Nothing going on from 2 to 3. Okay. From 3 to 5, negative acceleration. Sorry. Negative velocity, positive acceleration. That's another slowing down. From 5 to 6 to the same side, so that's speeding up. And from 6 to 7, negative, I've got positive velocity, negative acceleration, I got slowing down. So you can use either one of those strategies to answer the question about speeding up or slowing down. All right. In part B, I think we've answered a lot of these questions already. When is the acceleration positive? It's positive on the interval from 3 to 6. Where is, that's acceleration positive. Where is the acceleration negative? That looks like from on the interval from 1 to 2, and from on the interval 6 to 7. It's acceleration negative. When does the particle move with its greatest speed? In part C. In part C. Well, I don't know. That looks pretty far from the axis, right there. And this looks pretty far from the axis. Which one's further? I think they're about the same. So maybe at time equals 0, and on the interval from 2 to 3, that's when it meets with its greatest speed. And again, speed can be interpreted, a large negative velocity is a pretty fast speed. Okay. And then lastly, when does the particle stand still for more than an instant? Well, it stands still for an instant there, all right? Okay, but really it stands still for all of this time because we have a big long stretch of velocity equaling 0 on the interval from 7 to 9. All right? Okay, so I'm going to close off this recording, and then we can post that up on the website.